Filtering noise in LT8609 series DC-DC converters with TINA. DC-DC converters are indispensable in modern electronic systems for efficiently stepping voltages up or down. However, their inherent switching operation introduces conducted noise and ripple on both the input and output rails. Although usually small in amplitude, these disturbances can become critical in sensitive applications, such as precision measurement, RF front ends, or high-speed digital circuits. In this tutorial, we will demonstrate how to analyze, design, and implement appropriate input and output filtering for an LT8609 series step-down DC-DC converter using TINA, and verify the results to ensure stable, low-noise operation. To start with, open the LT8609 steady-state analysis.tsc file from the TINA examples, analog devices folder. Redesign the circuit using the design tool in TINA to obtain Vout equals 4 volts. Double-click the text box next to the circuit, and enter the required value in the Vout field. Press Run. The results of the quick analytic calculation appear instantly. As you can see, the changed components are displayed in red. Next, calculate the ripple in the input current, IN, and output voltage, Vout. Run transient analysis. The steady-state waveforms appear. To calculate the absolute and relative ripple of Vout and IN, first select the curves, then access the diagram window's process menu, and choose Ripple. The result is displayed in New Window. As we can see, the ripple of the output voltage is quite small, only 5.1 millivolts, while the ripple in the input current is very high, but may be acceptable due to the filtering in the main power supply. However, as mentioned in the introduction, these disturbances may cause problems in some applications, and therefore must be filtered out. To further filter the output voltage, a common solution is to add an LDO regulator, as it also acts as a low-pass filter that attenuates high-frequency components. The result is a cleaner, more stable output voltage, which is especially important for sensitive analog or RF circuits, microcontrollers, or precision sensors. Let's add an NR1700 adjustable output LDO regulator to the output, available in TINA, and an RLC filter to the input. You can easily do this using the circuit editor in TINA, but skipping the editing details for now, we get the following circuit. Now calculate the transient waveforms and the ripple of this circuit. Using transient analysis, we obtain the following waveforms. Finally, let's calculate the ripple values. The ripple values are now very low, within the microvolt and microampere range, making them acceptable even in sensitive applications. This concludes our presentation on filtering the input and output noise of DC-DC converters.
For more information, visit our website at tina.com. Visit our YouTube channel, youtube.com/user/Tina Design Suite.